vehicle?
Good.
Good? Good? Good spark? Light showing green.
So Masten has been a part of the Flight Opportunities Program since its inception. We were one of its first customers.
Copy that in progress.
There's a lot of benefits. One, we get to fly our rocket. We're always testing our own hardware. Two, we get to interface with like-minded individuals who have, at the end of the day, the same goals, which is to go to the moon, go to Mars, go to these other bodies. And so we get to interact with them, we get to understand how they do things. There's a transfer of knowledge both ways, and we build these strategic partnerships that are only going to facilitate these broader and deeper areas of exploration that we ultimately want to do.
Confirming that test site's up, vehicle payload are good, and we're ready to start the checklist.
So Masten is the flight provider of these flights.
Ground crew in position for a quick check.
We fly the vehicle through a trajectory that mimics that target destination, whether it's the moon or Mars, and gives them the fidelity of data that, again, they're not going to get with conventional means, whether it's a balloon, a helicopter, or an airplane.
Here we go. Masten ops to all, 6-second count to engine start.
So the Safe, Precise Landing Integrated Capabilities Evolution Project, or SPLICE, is developing a family of sensors that are required to land safely and precisely on the moon, Mars, and any other destination. The testing on rockets gets us even closer to that lunar landing-like test, where we can get as close as we can to the actual lunar landing here on Earth, allowing us to have additional confidence that our systems are going to work when we actually go to the moon.
Terrain relative navigation is a form of navigation in which you are able to determine your state of the vehicle relative to the terrain itself. So we're able to identify features pre-launch based upon satellite maps, load them onto the vehicle, and then we fly a camera on board which takes images. We compare those images to the maps that we've loaded with the pre-identified features, and from that we identify the features in the images captured, map them to the satellite maps, and then from that we can tell relative where we are to the terrain, so we can get altitude and whatnot relative to the terrain that we're seeing. So I think it's going to be critical for future flights. Most of the future missions that we're looking at are going to be pretty much autonomous, try to keep as much human interaction to a minimum. So in order to be able to navigate at the moon where we don't have GPS and other very accurate state information, terrain relative navigation is kind of your next best. The vision navigation portion of it is kind of the next best thing that we can go with. So I think it's going to serve a critical part in the upcoming return to the moon.
Also, as we move towards a sustained presence on other bodies like the moon, we'll need these precision landing capabilities in order to deliver cargo nearby where we have our crewed outposts.